This presentation involves expanding two brackets, which include surds. So by the end of this, you should be able to expand using the distributive property. And this will also include you recognizing and being able to calculate a conjugate surd, and we'll explain later what that is. All right. Just a quick recall, so we have already done this, but the distributive property for expanding two brackets, so you need to split the first bracket, or you could do the second, it doesn't matter, but split a bracket and multiply each individual term by the other bracket. So this here is an example, so x plus 3, 2x minus 5, you split that first bracket, multiply it by 2x minus 5, and then expand each of the individual brackets, collecting your like terms and ending up with a result. This is the same process that we're going to use for surds. Alright, so expanding with surds. Complete the distributive property as normal, and then apply algebraic manipulations and simplifications as appropriate. So simplify and add and subtract, multiply, whatever needs to be done with algebraic manipulations. So example 1, 2 minus root 3 and root 5 plus x. So we're splitting that first bracket into 2 times the second and negative root 3 times the second, and then expanding each bracket, so 2 root 5 plus 2x minus root 15 minus x root 3. Simplifying this, so we do have the ability to purely rearrange this. Note that none of our surds are simplifiable, so there's no root 15 is as good as it's going to get. It's not going to get any better. At this point, I'm really just rearranging to put my x terms first and then my constants, or my surds, 2 root 5 and negative root 15 at the end. Doesn't change my end answer, so I could have left it as this. That's perfectly fine. I've just grouped together my terms though. Next example, x root 2 plus root 6 and root 2 minus 3x. Again, splitting that first bracket, so x root 2 and root 6, so first bracket split, and then multiplying each of those two terms by this second bracket, so root 2 minus 3x and root 2 minus 3x. Now to expand just like normal, we're going to get x root 4 minus 3x squared root 2 plus root 12 minus 3x root 6. So that is your expansion. So note that as I've gone through and multiplied, I multiply the radicand with the radicand, I multiply what's out front with whatever's out front on each of those. And I'm going to keep going. My aim at this point is just to simplify as possible. So I've gone square root of 4 is 2, so 2x, and I'm also splitting that 12 into 4 times 3 to get out a simplification of 2 root 3. That's going to be my end answer. I can't simplify it any further, at least not easily at this point in time. The only other thing that you might want to do for that sort of question is to rearrange it. This is our x squared term, so that would be out the front. X and x in the middle, and then your constant on the end. For the purpose of what we're doing, you don't need to do that. Just be aware for in future that would be needed. Okay, conjugate surds. Conjugate surds are special surds because when you multiply them together, they always have a rational solution, so there's no surds in the solution. This is really powerful, especially for next lesson when we're trying to I suppose get this result of no surds in the solution. So conjugate surds, you can calculate them. They're the sum and difference of two different surds. So by the sum and difference of two different surds, what we're really talking about is taking one surd, or one expression, root 3 minus 2 root 5. And if you change this middle sign to a plus instead of a minus, you now have a conjugate pair. So these two here are classified as conjugate pairs. And then you can do the same for any, I suppose, term that we've got, or expression that we've got. 7 minus root 15's conjugate pair is 7 plus root 15. 12 root 2 plus 10 has a conjugate pair, 12 root 2 minus 10. So these are examples of conjugate pairs. And yeah, they're really powerful. We'll have a look at expanding now, one of these. So we do have a conjugate pair here. We've got a minus in the middle and a plus in the middle. So root 3 minus 2 root 5, root 3 plus 2 root 5. Splitting that first bracket, I've got root 3 and minus 2 root 5. And in my brackets, I've got my second one, root 3 plus 2 root 5. When I expand this, I get out some interesting things. I get out root 9, which is a square number, good. I get out 2 root 15, so root 3 times root 5 is root 15, 2 out the front, so 2 root 15. I'm also going to get another 2 root 15, but this time minus, so minus 2 times 1 is minus 2, 5 times 3 is 15. And then my end term is going to be negative 2 times 2 is this 4, and then 5 times 5 is 25. What you should notice here is a few different things. The first one is that the middle two terms cancel each other out. Okay? Plus this, minus this. It's like having plus 2 minus 2 is 0. So these middle two terms just cancel each other out. The other thing you should notice is that first term is 3, and that last term is 4 times 5, because the square root of 25 is 5. So in fact, we're just doing 3 minus 20, which is negative 17. So we've gone from having surds in our question to just having an integer number as our solution. Another example, so we've got 7 minus root 15 and 7 plus root 15. Again, splitting it, distributive property, just like normal. And again, you notice this same pattern where my middle two terms will cancel out. My first term is, in this case, a constant number because of the 7 here. And my last term is a surd, but it's a squared surd, so we can actually simplify this down to 15. So again, cancel out, change it to 15, and we get a result of 34. So surds in the question, but a rational answer. This one here, we have to create the conjugate ourselves. So 5 plus 2 root 7, 5 minus 2 root 7. So we have ourselves a conjugate pair, and then multiply these together using the distributive property. When we go through and do this, we're again going to have those two middle terms cancel each other out, and then the last term will be a surd squared, so a rational number. So we're going to have 25 minus 4 times 7, which is going to give us a result of negative 3. This process of finding the conjugate pair and multiplying them is very important for what we call rationalizing the denominator, which is the following lesson.